The next thing we'll learn about in this chapter is balancing chemical equations. Okay, remember we said chemicals on the left hand side of the reaction are the reactants and chemicals on the right hand side are the products. And on the arrow we will write conditions. Okay. So one important thing to keep in mind is that there will be same number of atoms of a certain element on both sides at the end of balancing, on both reactant side and product side. Okay, that means after the balancing is complete, the number of elements on the reactant side and the number of element on the product side of every element will be same. Okay, so let's specify this one of every element, not just one element, of every element will be same. Take an example of calcium hydroxide reacting with HCl to yield calcium chloride and water. Okay, this is a simple equation. If you look at it closely, there is one atom of calcium on the left hand side and one atom of calcium on the product side. They both are balanced, which is good. On the left hand side, there are two hydrogens. Do you see that? So it's calcium hydroxide written like this, right? That means there are two oxygens and two hydrogens. So there's two hydrogens plus one hydrogen. So totally there are three hydrogens on the reactant side and there are only two hydrogens on the product side. That means hydrogens not balanced. Chlorine, one chlorine on the reactant side and two chlorines on the product side. Chlorines are also not balanced. Two oxygens and one oxygen. So oxygen is also not balanced. One tip I wanted to give you is that if there is an element standalone by itself, for example Cl2 or O2 standalone by itself, try to balance it in the end, because what you can do is you can put any number here and balance it out. So it's easier that way. Most of the time it works. So one tip is, if there is a standalone element, it doesn't have to be a diatomic standalone element. If it is by itself, try to balance it in the end. Usually balancing that in the end works. Okay, so we realized that only calcium in this reaction is balanced. Oxygen and hydrogen and chlorine are not balanced. If we write this reaction again, calcium hydroxide reacts with HCl to yield calcium chloride and water. So for me, the easiest thing would be to balance chlorine, because there is 2 here and I can easily put 2 here. So now that means there are 2 chlorines and 2 chlorines. So chlorines are also balanced, and if you think about it, we did not touch calcium. So calcium and chlorine are now balanced. In that process, what we have done is we have increased the number of hydrogens. Now, previously there were 3 hydrogens, now there are 4 hydrogens, right? So there's 2 here and 2 here, right? 4 hydrogens. So I can make this a 2. So now there are 2 multiplied by 2. So there is 2H2. Okay. So H2 is like this, right? Like that, there are 2 H2s now in here, right? Okay. So 2 hydrogens here, 2 H2s. So that means there are 4 hydrogen atoms. So here there is 4 hydrogen atoms and there are 2 hydrogen atoms here and 2 hydrogen atoms here. So there are totally 4 hydrogen atoms on the right hand side and 4 hydrogen atoms on the left hand side, right? And there are 2 oxygen atoms here. So when you 2H2O, okay, 2H2O, it is like writing 2H2O in parenthesis like this. This is equivalent to that. What does that mean? That means that there is 2 of this entire molecule. Okay, so that will translate to, so if there is H, H and O, right, if this is H2O, there are 2 H2Os. So that means there are 2 water molecules. So totally 4 hydrogens and 2 oxygens, right? So when you write out the balanced equation would be calcium hydroxide plus 2 moles of HCl yield calcium chloride and 2 moles of H2O. This would be the balanced equation.